Okay, Advent of Code, day 17. Here we go. Rocks begin falling. Okay. Oh, it's Tetris. Oh, that's cool. Neat. Did you get pushed around by jets of hot gas? Okay. So there's left and right choices. I bet we're gonna add rotations next. That's cool. And then falling 1 unit down. Okay. The place it starts at is a little bit weird. So I gotta care about like relative to what. But anyways, I think what I'll do, I'll store each of these in a. I can't do 3x3. I have to do 4x4. So it starts here. The new rock begins falling. Okay, so the top left corner is the same. I think. Is that right? Let's see. New rock. Where's the new rock? Top left corner. It's the, like L-ish. Yeah. Okay. Cool. So we'll do. Gonna manually input these kinds of pieces. Okay, so this is one piece. Let's see, just so I can actually read the pieces, we'll do it like this. The next piece is going to be and then do 1, 1, 0, 0, 0, 1, and then verticals. And then finally, this. Okay. And we'll do like an infinite grid. And this is going to be, sure. Maybe I'll keep it as int, actually. And recur x and recur y will be 0, maybe? Wait, where does it, like, spawn? How high? Tall vertical chamber is exactly 7 units wide. Left edge is 2 units away. And its bottom edge is 3 units above. Oh, I see. So the x-coordinate spawn is interesting. Okay. That's going to be a little tricky, but I think we can do it. This is important. So if it gets pushed into a wall, I assume it just doesn't move. So that's relevant. So we're going to denote, we'll do like 0, 0 and bottom left. Bottom left, down is going to be 0 minus 1, right is 1, 0, left is minus 1, 0. Cool. And what we're going to do, yeah, and I think, so this is like inclusive or whatever. So, let's see. Yeah, so if it tries to go right, it fails. Okay. Okay. How do I want to do this? Just keep the input as for C. And what we'll do if that means push to the left. Yeah, okay. This means push to the right. Yeah, so we just do this, and then we do move down. Okay, and per piece, we'll do like move piece. So let's keep it px, py per piece. Piece ID is going to start off at 0. Piece x and piece y is going to be. These are wrong. I think I'll fix them in a second. Okay, so the move piece logic. Let's see. What we'll do. So new px, new py is going to be px plus dx, py plus dy. And what we'll check is we're going to check if for I in range 4, for j in range 4, if the piece x coordinate is going, the piece coordinates are going to refer to bottom left. So px, py are going to be bottom left of the 4x4 piece grid. Cool. And so our px, oh, whoops, that's going to be annoying. Let's do top left, just because now I can do this. And then this piece y is going to be, oh, this is annoying. It's my coordinate system. I really need to make sure this is correct. Like, I gotta be very careful here. Okay. So if I go from 0 to 3 for the indexes here, we're gonna start here. If we add 1, that's gonna correspond to actually adding 1, but then adding 1 to y, if this is the piece xy, is actually going to be like subtracting a 1y in my other coordinate system. So I think it's going to be this. We're also going to do if pieces of PID of ij. We don't actually care if it's a 1. And so here's the new coordinate. And what we'll do is we will say so this is going to move the piece if it can. Okay, yeah, let's do this. Yeah, and then if RPX is not in range 7, we're just going to fail. If RPY is less than, I think if it's just less than 0, we fail. And then finally, if grid of RPX and RPY not equals 0, we fail. So we can't move into a piece, we can't move out of bounds. If all these checks succeed, piece can move. Yay. If this happens, we are going to actually move the piece and return true. Okay. So this does modify state. I think I'm going to have to do px, py. Let's do grid, PID, everything. Okay, cool. And now the move down. So if one of these fails, it's whatever, right? But if the move down fails, we actually have to place it. So if move piece 0, whoops, oh, this is wrong, by the way. That's good catch. So we're going to move this down 1. So if this fails, we need to place the piece. So we're going to iterate through the piece coordinates, get the piece's absolute coordinates, and oops, and then we're going to set it in the grid. Also add an assert, why not? Because like clearly it should be 0 everywhere when we lock a piece in. Set this to 1 for a locked in piece, and yeah, I think that's it. If it fails to move when it's moving downwards, we just lock it in. Cool. So now the next thing is, oh sorry, and if we lock it in, there's another thing we have to do, which is, oops, let's also add the globals. If we, yeah, let's return return false. So if we can't move it down, piece is locked in, piece is now locked, add new one. And what we'll do, how many units? That's a lot of rocks, but okay. Let's just do highest. Yeah. Well, we'll do the dumb thing for now. I'm gonna fix it later. Max y is going to be start off as 0, and then for y in grid, if he is 1, max y, max y, and y. So now we know the max y coordinate. We need this to place the next piece, or to start the next piece. The next piece is always going to start at x equals 2. Is that right? 0, 1, 2. That is right. So the piece x is going to be 2. The piece y is going to be, let's see. So there's always 3 spaces, right? This is going to be annoying because we got to figure out how many with the lowest 0 is here in the next piece. So the next piece ID is going to be, let's bump the piece ID. And then piece lowest. Here, let's just do this actually. I'm just going to hard code it. That way I don't need to write logic. So this one has 3 zeros on the bottom. Next one has 1 0. Next one has 1 0. Next one has 0 zeros. The next one has 2 zeros. So this is going to sort of correspond to like our offset. Cool. And this okay, so after the first rock, I'm just going to trace an example to figure out. Okay, so we want to have 3 zeros in between. So what that would correspond to, here the max y would be 0. So max y should start off as -1, I think. Just note, max y starts -1. Probably. Is that right? Yes, that's right. Okay, so we're going to have 3 zeros. So what is that going to mean? It's going to mean that we want the top. So in this example, we want the top to appear at 0, 1, 2, 3, 4, 5, 6. We want it to appear at 6. We have 1 0 on the bottom here. So it's going to be max y plus, let me think, max y plus 3 plus 4 minus 0's bottom is a 6. So if it was 0, 0's on the bottom of this piece is 1. I think that's right. And let me check it for another example. So in this case, 0, 1, 2, 3. 3 would be the highest coordinate. So it would be 3 plus 3 plus 4, so 10 minus 0's bottom. There's 1 0 on the bottom of this as well, so it would be 9 is going to be the coordinate here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, perfect. This is the right formula then. So the new PY is going to be max y plus 3 plus 4 minus 0's bot. 0's bot is going to be P low of PID. Okay, so I think this is actually also what we're going to start the piece off at. I told you I was going to fix it. But the max y starts off as -1. So I think this is right. And then, okay, so do these things just loop? The jet patterns? How long are the jet patterns? Okay, I did have an error. New piece X. Whoops, did I delete something? Oh. Oh, this is just old piece X. Cool. Okay, so it does a thing. How long is the input? Okay, it's pretty long. Let's see. Let's make sure it's dropping pieces. Okay, it looks like it is. just gonna make sure that it looks like, okay, yeah, so like pieces should on average take like maybe like 3 to drop. This seems like a lot actually. Oh, I guess this includes the piece spawn. That's fine. Okay, cool. So what happens to the vents, sorry, when we loop? At the end of the list is reached, it repeats. Okay, so yeah. I think this is fine. We just loop this. Num pieces. Oh, whoops. I already used that variable. While num pieces. This is gonna be like a number of pieces locked in. After 2022 rocks have stopped falling. Cool. And then in this case, we're going to add one here. And then once they have stopped falling, let's just run that. That seems pretty slow. How slow? Oh, whoops. There's a bug. Oh, that's pretty close. Which is if num pieces is greater than 2022, it's gonna break. Cool. And now what we're gonna do is what we care about is the max y. So we're sort of just gonna repeat this again. Except note that now we're gonna print max y plus 1. Like that'll be our answer because it's how tall the tower is. This should be not the right answer. Okay. Had to go for speed, you know? I think that's fair, maybe. So we'll try this for starters. Try the sample input. And then on the sample input, let's do, why don't we like, after every movement, we'll print like the bottom part of the grid. So we'll go from like, so x is 0 to 7. Sorry, this fails at 7, right? Yeah, I think so. Cool. If grid x, y is 1, else done. And for x in range 7, that's fine. And then this part is going to be for y in range. We're going to go down, so let's start at like 50, go down to, we want 0 inclusive, so I think this is what we want. I think I do just want to see these, but let's just do 20 lines for now. Okay. Sorry, I want to do so I can actually see it fall. So the first piece locks like this. That doesn't look right from the start. Why doesn't that look right? Oh, are these things transposed? Do I need to transpose them? That would be quite annoying, but maybe fine. Let's just transpose them. That was a little silly. I already had that one written. This one's already transposed. This one's already transposed. Oh, that was actually pretty easy to fix. That could be a nasty bug. I mean, it was a nasty bug, I guess. Hello? Did it not? Oh, this is after each character movement. Okay. And then, yeah, so we're not going to be showing the, that's fine. We're not going to be showing the pieces as they're falling. This one should lock in here. That looks good. This one should lock in here. And then the L locks in far left. Tucking in there. And then the vertical piece locks in here. Okay, this looks pretty good now. So I'm going to try this again without the sample input. And our answer is going to be this. Okay, rank 46. Oh, no. Okay, so the trick is, wait, what is the trick? Oh. This is too many to even simulate. Like, even if we like only track the bottom of the grid, this is just too ridiculous. So what we can do, so the state of the game is completely described. State is completely on a piece lock-in, the state is described by, what is it described by? It's described by the top of the tower. So like this could be like 7 ints of depths from looking from above, basically. That is one thing we need. Another thing we need is the next piece ID. The next thing we need is going to be where we are in the vent sequence location. And I think this is unique. And basically, the first time we see this reappear, we can like sort of immediately simulate everything. Sorry, like if this appears like 100 turns later, then we can just modulo this by 100 because we know that it's gonna like repeat itself. Or sorry, it's not literally modulo, but we're going to like we'll just do it. And then I can explain after because time is of the essence. Okay, so how do I track this? So the first thing I need to do is vent ID. I need to keep track of that. The next thing I need to do is generate view from the top. Oh yeah, so gen top view. So this is going to be basically what I'll do is I'm just going to keep track of like the max Y I've seen. And this is going to be -1 for this in range. Let's do like, yeah, just something weird. I guess the -1 would have been possible. That's fine. 7 and then 4 x, y, v, and grade the items. If we see something, the max y's of x, max of the max y's of x, and the actual y we see. Okay, and then what we can do is we can do the max and max y's, and then max y's minus, or sorry, let's call it m minus b for m and max y's. So this is now like a view from the top, where the very top y is at like 0, relatively speaking. So we should just be able to run this, or what we have here, and like see it work. Whoops. Yeah, that looks fine. -53 is a little bit questionable, but that seems feasible, right? Like we just never put anything there. The other thing is I want this to be hashable, so I'll just do this. What else? Okay, so we need the top view. We need the piece ID, the next piece ID, and we need the vent sequence location. So we'll do scene, and basically what we'll do is we'll track what the height was the last time this was seen. So whenever we add a new piece, what we're going to do is we're going to do add to scene. So top view, gen top view. The piece ID is just PID. And the event sequence location is just VID. So scene of top V, PID, VID. Well, first, if top V, PID, VID in scene, just alert. We'll get to that case. And what we're going to set it to is going to be like the current height. Wait, what? Sorry, no, we care about the number of pieces and the current height. And let's just see if this repeats before 2022. I don't think it will. Yeah, it doesn't look like it does. In fact, it's a lot slower now too. How big is scene getting? Scene is getting pretty small. That makes sense actually, that it doesn't get very big. I'm gonna let this run for a little bit because I would like to have an idea of what the num pieces is. Whoops. When we get there, and then I can keep coding the rest of it. Okay, so when we see this repeated, what does that mean? It means that old numpy. Okay, cool. That doesn't take very long. Sweet. Please stop. Okay, so the old num pieces is going to be scene of this PID, and then the old max y. And now what we can do is we can sort of jump ahead, like additional. Let's see. So we know that like if we place another numpy minus old numpy pieces, right? We arrive in the same configuration with height max y, old max y, with extra height. Okay. And if this happens, basically what we can do is we can say this many rocks divided by, I call them pieces, but they are rocks. Let's scroll up. So this is how many times we want to repeat this. Repeat, it's going to be this. Technically, we don't want to overshoot. So this is how many times we're going to do it. And we're sort of going to simulate what would happen. So num_p would increase by let's do this new condition is going to be num_p less than this. And then cool. Yeah, so the num piece is going to increase by num_p minus old num_p times the number of times we repeat. The additional, this is going to be our tracker for the extra max y we add, is going to be repeat times max y minus old max y. And then after here, we can sort of just keep going. I'm going to reset scene, just so we don't print again. But at this point, it should be less than one full extra period until we hit this our num_p threshold. So this should just work, maybe. But we're going to be adding additional here. Okay. Fingers crossed. I probably should put it in here. Anyways. And then I don't actually know what I'll be able to do with this, but okay. So 5008 plus additional is going to be this number. Rank 11. Oh man. Yeah, so part one, I was definitely a little bit on the slower slide. Oh, hey, Antonio got number 1. Oh, wow, number 2, number 1. Yeah, of course, he jumped ahead of me now by 12 points. But yeah, that was still a good. That was a really good day for me still. This 11, I think I'm more proud of than the. I mean, well, obviously, I'm more proud of this than the 46. I definitely stumbled a little bit on this. Some amount of time was lost to like this like transpose thing where I mixed up my x and y coordinates basically. Let's see, if I lost like a minute and a half to that, how much would that have accounted for? 1835, not even a whole lot. That would have not been that much. Wow. So basically like top 10 here was a whole like, whoa, 5.5 minutes ahead or something. I wonder how I could have done it that quickly. Probably my code is a little bit on the like verbose side. I don't know. I think I was being very careful about the structuring of move piece and move down. I've written Tetris a few times before, like just reference Tetris implementations, and not like to spec implementations, but just like for fun versions of Tetris. And there, it's like, this is a very nice pattern. Well, obviously this code is not nice, but the pattern itself is nice of attempt to move and like only do the move if you can do it. If the move down fails, then lock in the piece. That just like works very well. Yeah. So I was doing that partially because I expected rotation to come up for part 2. Like, what I expected it to be was something like, if you see like left, left, that means move left. If you see like this, that means rotate clockwise. If you see right, move right. And then if you see this, rotate counterclockwise. I completely expect it to be this for part 2. And I'm a little, well, maybe I'm not sad because that would have been painful to write. But it would have been pretty funny if my prediction was exactly correct. But it was not. To be fair, I think what it actually ended up being is more on brand for Advent of Code. One of the things that Eric likes to do is this type of thing where you do a simulation, and so I guess I'll start getting into like explanation now, where you do this simulation, and part 1 you just simulate it, and then part 2 is like, there's like 2 versions of this. Part 2, version 1 is the second part has like a larger number, but not so large you can't just directly simulate it. It'll just be like kind of slow to simulate. That is one thing he likes to do, and the other thing he likes to do is just make the second number so ridiculously large that you could never hope to simulate it. And in those cases, what you basically have to do is you have to abuse the fact that there's like a repeating pattern. So in this case, the idea is that like all you care about is the height of the tower, and you care about the height of the tower, and like you need to be able to know how to place pieces, but you don't actually care like anything that's below on the big chunk of the stack. In this case, we need to care about all of this, or not, maybe not all of it, but basically all of it, because like the vertical line piece could fall down in this corner. But if this were like blocked up, for instance, you can imagine that you could just like chop off everything here and below, because it just wouldn't matter to you. So that's kind of part of the idea. And the other part of it is that like, so you have that, and then like things basically repeat. As these, like you always loop through pieces in the same order. You always go through the vent directions in the same order. So it's really just a matter of like, I've seen this current top of the tower pattern before, and it's going to repeat after I place another like 3,000 blocks. That is a totally possible thing. Sorry, whenever I say piece or block, by the way, that means like rock in the context of this question. But yeah, you just know that you'll repeat at some point. So one of the things you can do is you can basically simulate it, keeping track of, oh, sorry about that, keeping track of the state that you have like seen so far, like the top of the tower, the ones you've seen so far. And whenever you see a repeat, you know that you're going to repeat. Or like that you'll just keep repeating that pattern, basically. If that makes sense. I think like an example would help, but it's kind of hard to do examples for this. But like if you see a pattern of numbers and you know that like one number always follows the next, right? So like sort of here's the general statement. If you have some function f of like from x to x, and you observe a sequence where like each element is f applied to like the previous element, right? And you sort of see like a is like 1, 3, 8, 4. I'm putting numbers here, but like these could be any kind of object. 9, 14, 8. If I see this, what do I know has to happen? Well, I know that like we already saw an 8. I know that 8 maps to 4, and 4 maps to 9, maps to 14, maps to 8. So I know that this pattern is going to repeat indefinitely. I don't actually need to keep evaluating. So if you saw this, and I asked you like, what's the, I don't know, like, let's do something ridiculous. 1/1000th term in this sequence, you'd be able to figure it out pretty easily because you know it's going to be one of these, and you know that these terms, like, you know that they repeat in like the cycle of 4. Sorry, is that 4? 1, 2, 3, 4. Yeah. So what you can do is you can sort of see where this 8 happens, and then fast forward yourself all the way up to like just before the 1 millionth turn, and then manually simulate the last part of the cycle. Depending on like exactly the question setup, I think there's different ways of coding this. I like to think of it as fast forwarding yourself because it's easiest to not write bugs that way. But there's definitely like a lot of different ways you can do it. Yeah, this problem is basically like that, except instead here x is like the state of the like the top of the state here. And there's like one more caveat, which is that there's another sequence B here where like this is like the height. And you can imagine like oh yeah, so you can imagine this like another function g, which also maps like, how do I write this best? It's not like x to y. It's like, sure, it's like y to y. And here these are like the heights. What's something we could do? We could just imagine it's like the length of the sequence. It doesn't matter what it is. But, how did I want to do this? Okay, I don't want to formalize this right now. But I think like it's not hard to convince yourself that if you are looking at a sequence like this and you know that the height of your tower increases by like 3 in this cycle, every extra cycle you go through is it's going to repeat by 3. So yeah, that's exactly what I did here. I keep the scene dictionary, which basically just maps like the states we've seen so far to like when we saw them, and as soon as we see a repeat, we fast forward ourselves up to like the future, just right before this, and then we keep going until we finish it up, until we hit this, and then finally at the very end we hit we print this plus additional. But yeah, that is day 17. Don't really have much more for that. Let's see if the leaderboard is capped yet. I bet it has. It's gonna come in fast here. Oh, I guess it hasn't quite yet. Oh, why are there so many sponsors here? What's going on here? Are these all the same? That's a little bit fishy, I have to say. Well, anyways, yeah, I'll call the video here. It was a good question, and I'm happy with my performance on that. Cool. That's it for today.